am I doing with my life? I should make a garden. I've always wanted one ever since I was a kid.
Hey, did you just say you want to make a garden? Because, I happen to be an expert at making gardens. If we're going to do that, though, you're probably going to want to start out with the trapezoid garden.
A trapezoid garden, huh? That sounds like a terrific idea.
Before you do that, though, there's some things you got to know. For example, do you know the surface area of a garden spade?
What do you mean by the surface area of a garden spade?
Well, I mean, you can't really find or make a garden without finding the area of a garden spade.
Okay, so how do I find the surface area of a garden spade?
Well, first, you're going to have to know what the shape of the garden spade is.
Well, the shape of my garden spade is a kite.
A kite is a quadrilateral that has one pair of opposite congruent angles, diagonals that are congruent, and two pairs of consecutive congruent sides. The formula to find the area of a kite is A equals 1/2 of diameter 1 times diameter 2. To find the area of a garden spade, which is shaped like a kite, you need to first write the formula, then plug in the values, and from this point on, it's algebra. Now that we know about kites, let's practice finding a kite's area, or in this case, a garden spade. In this problem, we first need to write our formula. A equals 1/2 of diameter 1 times diameter 2. After that, we plug in our values. Diagonal BD is given to us, but diagonal AC is not. So to find the measure of diagonal AC, you're going to need to use Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So to find diagonal AC, we will need to find two separate sides. First, we'll find the shorter part of AC, which will look like 2 squared plus x squared equals 3 squared. Solving this equation, we get the square root of 5 is the smaller part of AC. To find the longer part of AC, you're going to do the same procedure as before, which is Pythagorean theorem. So it will look like 2 squared plus x squared equals 5 squared. And when solved, we get the square root of 21 as the longer part of AC. Now that we know our diagonals, we can finish plugging in our values into our area formula. A equals 1/2 of diameter 1 times diameter 2. After plugging in our values, we get 1/2 times the square root of 5 plus the square root of 21 times 4, which, from this point on, it's plain old algebra. And when solved, we get approximately 13.64 when rounded to the nearest hundredth. Some common misconceptions are as follows. For number 1, according to Miss O'Hara, diamonds are not shapes. Kites and diamonds are not the same, so don't call them diamonds. Some people often mistake a kite for a rhombus. However, rhombuses have 4 congruent sides, while a kite does not. A common mistake Daniel makes is that he forgets the diagonals are perpendicular. The diagonals are in fact perpendicular. Also, sometimes but rarely, Daniel mistakes the side for the diagonals. The diagonals are inside the quadrilateral.
Now that I noticed, I can actually start the real garden.
Wait. You need to know the properties of trapezoid before you start.
What are the properties of a trapezoid?
Well...
A trapezoid is a quadrilateral or a four-sided figure with exactly one pair of parallel sides. For example, trapezoid TUWV has one set of parallel sides. Therefore, it is a trapezoid. The trapezoid you're probably used to seeing is an isosceles trapezoid. What makes this type of trapezoid different is that its diagonal, legs, and base angles are congruent. The area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now that we know about trapezoids, let's practice finding the area of one. We are going to need to find the area of this trapezoid garden. To do this, we need to first write our trapezoid area formula, and then we plug in the values. Then we need to solve our new equation, and that's how we end up with our answer. So for this problem, first write down the area formula for a trapezoid. A equals 1/2 base 1 plus base 2 times the height. Then we need to plug in our values. In this problem, our first base is 4 feet and our second base is 9 feet. The height of the garden is 2.5 feet. Plugging these in, we get 8 equals 1 half 4 plus 9 times 2.5. Now we solve the equation using the order of operations and end up with 16.25 feet squared. Trouble spots for trapezoids. Number 1. The most common misconception about trapezoids is that it always looks like an isosceles trapezoid, in which the diagonals, legs, and bases are congruent. However, for a quadrilateral to be a trapezoid, it just needs to have one pair of parallel sides. Number 2. The second most common mistake beginner geometry learners make is that they mistake the sides for the bases. In order to find which pair of sides are the bases, just look for the parallel sides. Number 3. A mistake that Daniel always makes when finding the area of a trapezoid is that Daniel always uses the lengths of the side instead of the height. Don't be a Daniel, actually use the height.
Okay, so can I start the garden now?
Yeah, sure. I think you're prepared now. Go show the earth what you got.
Okay, I'll try my best.
Whoa! Have you considered making a kite garden? I honestly think it'd look a lot better.
Oh, okay, I think I get it. I'll go ahead and start that.
Whoa, wait. Do you even know what a kite is? With the kite, there's a whole new set of rules and properties you've got.
To find the area of a kite-shaped garden, we'll follow much of the same process as before. Remember, a kite is a quadrilateral with one pair of congruent opposite angles, congruent diagonals, and two pairs of consecutive congruent sides. Also, remember the area of a kite is A equals 1/2 of a first diameter times second diameter. With this in mind, let's review our steps. First, write the formula, then plug in the values. Next, solve the equation, and finally end up with your answer. Now that you're refreshed, let's find the area of this kite-shaped garden. First, rewrite our formula, A equals 1/2 of the first diameter times second diameter, and then plug in our values, which are 10.5 feet and 22.6 feet. After plugging in our values, we then need to solve our new equation. First, multiply 10.5 and 22.6, which will get you 237.3. Then divide 237.3 by 2, which will give you a quotient of 118.65. Now that we have solved our equation, we can now write an answer of 118.65, which is the area of our garden.
I think you're ready, Daniel. You become a master.
Thank you, Ross.
Hey Ross,
Oh, hey, what's up?
I heard you showed Daniel how to make a kite-shaped garden.
Yeah, I totally did. Dude, that guy's so gullible.
He's such a retard too.
Yeah.
Yeah.